Hi everyone, welcome back to my channel. Today we're going to take a look at another interesting topic. We're going to discuss magnetars versus neutron stars. And neutron stars are already some of the strangest objects in the universe. So what they are is basically the crushed remains of massive stars, packed so densely that a tiny amount of their material would weigh an unbelievable amount on Earth. But as extreme as neutron stars are, some of them become even more extraordinary. So these are called magnetars. So what exactly is the difference between neutron stars and magnetars? Are they like completely different objects? Or is it just one being more extreme version of the other? So let's take a closer look at that. When a massive star reaches the end of its life, it can explode in a supernova. What remains after that explosion depends on the mass of the original star. In some cases, the core collapses into a neutron star. A neutron star is incredibly small compared to a normal star, usually only about 20 kilometers or around 12 miles across. So yet despite that small size, it can contain more mass than our own sun. So that means neutron stars are unbelievably dense. They are so dense because gravity has crushed to the core so intensely that protons and electrons are forced together, forming neutrons. The result is an object made mostly of neutron-rich matter packed into an extremely tiny volume. So all magnetars, in essence, are neutron stars. But not all neutron stars are magnetars, and this is the key difference. A magnetar is a special type of neutron star with an extraordinary powerful magnetic field. In fact, magnetars have the strongest magnetic field ever observed in the universe. Neutron stars do already have strong magnetic fields, but magnetars take that to a completely different level. To understand the difference, imagine a normal neutron star as already being like one of the most extreme objects in existence. A magnetar is what happens when that same kind of object becomes even more intense, unstable, and violent because of its magnetic field. And this magnetic field is basically what defines a magnetar. It can be thousands of times stronger than the magnetic field of an extraordinary neutron star and vastly more powerful than anything we could ever create on Earth, for example. So that intense magnetism affects everything about the magnetar. For example, it can twist the star's crust, trigger violent starquakes, and release huge bursts of X-rays and gamma rays into space. These outbursts can be so powerful that even from thousands of light years away, scientists can detect them. So while a neutron star is already the collapsed core of a dead massive star, a magnetar is a neutron star whose magnetic field is so extreme that it behaves far more dramatic and energetic in many ways. Another difference is, for example, how they are observed. Some neutron stars are detected as pulsars, and a pulsar is a rotating neutron star that sends beams of radiation into space. So if those beams sweep across Earth, we detect them like pulses, almost like a cosmic lighthouse. Magnetars can also pulse, but they are more famous for their violent eruptions and unpredictable outbursts or high energy radiation. So if neutron stars are the compact and dense remains of stellar collapse, magnetars are like the most chaotic and magnetically overpowered members of that same family. Now let's make the comparison, for example, even simpler. A neutron star is the broader category. Magnetar is a rare subtype of neutron star. Both are born from the deaths of massive stars, and both are incredibly dense. Both are small, compact stellar remnants. But magnetars stand out because their magnetic fields are vastly stronger, and because of that, they can be much more violent and energetic. You could think of it in a way that, for example, every magnetar is a neutron star, but a magnetar is a neutron star pushed to magnetic extreme. Scientists are especially interested in magnetars because they allow us to study physics under conditions that cannot be reproduced on Earth. Their behavior may help us better understand matter, gravity, magnetic fields, and the strange limits of physics itself. And that part of what that is part of what makes them so fascinating. They're not just dead stars. They're some of the most extreme natural objects that the universe has ever created. So again, what is the difference between a magnetar and a neutron star? A neutron star is the dense collapsed core left behind after a massive star dies. And a magnetar is a neutron star with an unbelievably strong magnetic field, powerful enough to trigger violent bursts of energy and make it one of the most extreme objects in the cosmos. In other words, magnetars are not separate from neutron stars. They're rare and more extreme kind of neutron stars. And in the universe is already full of strange and powerful objects. Magnetars still manage to stand out in that regard. So thank you for watching. I hope that it was interesting. I hope that you learned something new. And take care.